Hey guys, so we're going to be learning about sequences, series, and sigma notation. In this lesson, we're going to learn what a sequence is, how to find the terms of a sequence, and what sigma notation is, and how to use it to calculate sums of series. Some important terms that we're going to go through in these notes are what a sequence is, a function with a domain of positive natural numbers. There's two types of a sequence, a finite sequence, which has a certain number of terms, like 8, 9, 10, and 11, or an infinite sequence, which has an infinite number of terms, so 8, 9, 10, 11, and it goes on and on. A sequence is made up of terms. They are a set of numbers. Another term is an explicit formula. This is a formula where the value is not found using the previous term. So we'll do a couple of these formulas. And then there's also a recursive formula. That's a formula where the value is found using a previous term. So a term that you already know the number. Converge is another term that we're going to go through. It's when a sequence that has a limit approaches a unique number. That can be like 0 or a limit. And then also diverge. When a sequence does not have a limit, it diverges. Series, a sum of terms in a sequence. There are two types of series. There's a finite series, where the sum of terms in a finite sequence. So if the sequence is 8, 9, 10, 11, the series would be 8 plus 9 plus 10 plus 11. An infinite series is when the sum of terms is the sum of terms in an infinite sequence, like 8, 9, 10, 11, dot, dot, dot. So you do 8 plus 9 plus 10 plus 11 plus, and it'll go on forever. Also, we use the term nth partial sum. That's the sum of n terms in a sequence. And the Fibonacci sequence, a sequence of numbers when each number equals the sum of the two numbers before it. So you do 0 plus 1 is 1, 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 3 is 8, 8 plus 5 is 13. Yeah, keeps going on. That's the Fibonacci sequence. And then sigma notation, a method used to write out a long sum in a concise way. So this is the symbol, and then the upper limit is b, but it's usually n, and then the lower limit is right here. So if you were going to show this sum using sigma notation, you would write the symbol with n and r equals 1 to the ur. So the upper limit is n right here, and it starts at 1. Okay, now we're going to do some examples. So for this set of examples, we want to find the next 4 terms of the sequence. So the common pattern here is add 3, so you're going to write plus 3, plus 3, you get it. So this one's just a simple one, so 10 plus 3 is 13, plus 3 is 16, plus 3 is 19, plus 3 is 22. This is just a basic one, but it's going to get a little harder as we go on. So the next one, you just have to find the pattern. So 30 to 29 is minus 1. 29 to 26 is minus 3. And 26 to 21 is minus 5. So it seems like it's just going like every odd number, and you subtract it by 2, so next one would be minus 7. So 21 minus 7 is 14. So you can just write it right here. Minus 9. 14 minus 9 is 5. And then minus 11. 5 minus 11 is negative 6. And then the last one is minus 13, and negative 6 minus 13 is negative 19. Okay, now we're gonna use this formula to find the next 4 terms. So you're going to plug in 1, 2, 3, and 4. So a of 1 equals 1 squared is just 1, plus 5 is 6. A2, 2 squared is 4, plus 5 is 9. A3 is 3 squared, which is 9, plus 5 is 14. And then A4 is 4 squared, which is 16, plus 5, which is 21. So those are the 4 terms. Okay, so for example 2, we're going to find the 6th term of the recursively defined sequences. Recursive formula from here is a formula where the value is found using a previous term. So we're going to use previous terms. So in this one, the previous term is A1 equals 3. So we already know that A1 equals 3. So we're going to write A1 equals 3. Then we're going to write A2 is 2 times A to the 2 minus 1, because you're just going to plug in 2 for anywhere it says n, like right here. So A to the 2 minus 1 is just A to the 1. So we're going to do 2 times 3. So that's 6. And then we're going to do A to the 3 equals 2 times A to the 3 minus 1. So that's A to the 2. So that means we're going to do 6 times 2. So it's 12. Now A to the 4 is 2 times A to the 4 minus 1, which is A to the 3, which is 12. So that's 24. A to the 5 is 2 times A to the 5 minus 1, which is 24 times 2, 48. And then A to the 6, which is the number that we're looking for, is 2 times A to the 6 minus 1, which is 48 times 2, which is 96. So A to the 6 equals 96. The next one is really similar, so we're just going to do A to 1 equals 10. A to the 2 equals A to the 2 minus 1 plus 5. So we're going to do 10 plus 5. 15. A to the 3 is A to the 3 minus 1 plus 5. So 15 plus 5. So you're going to sense a pattern once you keep doing each number. And for this one, it's just plus 5, the previous term. So 25, 8 to the 5 is A to the 5 minus 1 plus 5. 30, and then A to the 6 is 35. You're just going to write A to the 6 is 35. I like to highlight my answers, but you can do whatever you like. Just so you can see which one is the end. Alright, this is the last page of our notes. So for this one, we're going to determine if the following sequences are convergent or divergent. If you look back at our definitions, we said that when it converges, it's a sequence that has a limit, approaches a unique number, and diverges when a sequence does not have a limit, it diverges. So 30, 28, 24, 18. So this seems like it's not going to a special number, and it seems like it's just gonna go on and on. I forgot to write. So we're gonna say this diverges because it doesn't have a limit. The next one says limit of 2, so that kind of gives a hint that what we're gonna choose. So it goes 2.1, 2.01, 2.001, and 2.0001. So it seems like it's approaching a unique number, which is the definition of convergent. So we're gonna write convergent. There's a bit harder ones in your practice worksheet that we're gonna work on, but those are pretty basic. So for example 4, we're gonna find the 4th partial sum of the following. So for this one, just gonna plug in the numbers. So a1 equals 3 to the 1 plus 1. So 3 to the 1 is just 3, plus 1 is 4. A to the 2 is 3 to the 2 plus 1, which is just 9 plus 1, which is 10. A to the 3 equals 3 to the 3rd plus 1, which is 27 plus 1, which is 28. And then a to the 4 is 3 to the 4th plus 1, which is 81 plus 1, which is 82. So the fourth partial sum is you write s to the 4, and then you add all of these. So 4 plus 10 plus 28 plus 82, which is 124. Okay, so the next equation is a lot like the last one, except it's in fraction form. So we're going to do the same thing. So a1 is 4 over 3 to the 1, which is just 4/3. a2 is 4 over 3 to the 2nd, so that's 4/9. a3 is 4 over 3 to the 3rd, which is 4 over 27. And a4 is 4 over 3 to the 4th, which is 4 over 81. Alright, so now we're going to have to find the sum of these four terms. So we're writing S4 equals, and we have to make these all have the same denominator, which is, we're trying to get it to do 81. So 3 times 27 is 81, so we're going to multiply it by 27 over 27. So that's 108 over 81. 9 times 9 is 81, so 9 over 9. 36 over 81. And then this one is 3 over 3, so it's 12 over 81. So we're going to add all of these numbers. So 108 over 81 plus 36 over 81 plus 12 over 81 plus 4 over 81 equals 160 over 81. And you can't really simplify that much, so we're just going to leave it like that. And I'm going to go back and highlight these two answers. S4 equals 124, S4 equals 160 over 81. Okay. And here's just a little tidbit of information to remember, that if an infinite series converges to 0, it has a sum. Okay, so next one, for example 5, these are the last few questions that we're going to do. We're using sigma notation to find each sum. So we're starting at n equals 2, and we're ending at n equals 4, so that's just 3. So 7 times 2 minus 1 plus 7 times 3 minus 1 plus 7 times 4 minus 1. And I need to start at 2 because n equals 2, and I need to end at 4 because that's the upper limit at 4. Okay, so now we're going to find each number. So 7 times 2 is 14, minus 1 is 13, plus 7 times 3 is 21, minus 1 is 20, and 7 times 4 minus 1, well, 7 times 4 is 28, minus 1 is 27. So we're going to add all of those, and this equation equals 33, 40, 60. And we're going to highlight that answer. And then the last one, the lower limit starts at 1, and the upper limit starts at 5. So we're going to start at 1, so 3 times 1 is 3, plus 2, 5 over 2, plus 2 times 3 is 6, plus 2 is 8, over 2 plus 1 is 3, plus 3 times 3 is 9, plus 2 is 11, 3 plus 1 is 4, plus 5 times 3 is 15, plus 2 is 17, over 6. Oops. I skipped one. 4 times 3 is 12 plus 2 is 14 over 5 plus 5 times 3 is 15 plus 2, which is 17 over 6. Okay. This one's 5. So now we're going to have to make these all have a common denominator. So the common denominator is 60. We're just going to put them all over 60. So multiply that by 30, so 150. Multiply this by 20, so 160. Multiply this by 15, so 165. Multiply this by 12. So we're gonna get 168, and then this by 10. So 170. And then once you add up all of those, you're gonna get 813 over 60. And then once you simplify that, you get 271 over 20, or you could even do 13.55. Okay, so the notes are done. I have attached a practice sheet for you to do after this. I can't find it right now, but it'll be in the document. And you're all set. Have a great day.